Okay, so we continue our quest to find surface area. So we have chopped our domain into little pieces, and we have approximated. We had a bunch of rectangles in the domain. We approximate that the area over the ijth rectangle is the area of the portion of the tangent plane that lies above that rectangle. And we determined that it was given by this formula. It was the square root of the partial with respect to x at our representative point squared, plus the partial with respect to y at our representative point squared, plus 1, all multiplied by delta x, delta y, which of course we can call delta a. Okay. So now we're going to add these all up. So we're going to have the sum as j goes from 1 to n, sum as I goes from 1 to m, where this is just keeping track of the number of pieces into which I've chopped things this way and this way, of tij, which is the square root of f sub x at my representative point squared, plus f sub y at my representative point, it's an I, squared plus 1, times, I'm just going to write, well, I'll write delta x, delta y. Okay, so this is a Riemann sum, which is very exciting, because of course we know that step 4, we're going to take the limit. So we'll take the limit as m and n both go off to infinity. The important thing, of course, is that we've chopped things into smaller and smaller pieces. If we chop things into regular size pieces, then m and n going to infinity ensures that all of those pieces will be small. But this then becomes the double integral over d of just the square root of f sub x squared plus f sub y squared plus 1 dA. And of course, when I write it as an iterated integral with individual limits of integration, that's going to be just a dx dy. Pretty nifty that this actually works out. Okay. And if you compare this formula to the formula that we had for arc length, when we had arc length, we were talking about a function of just one variable. Okay. But we can calculate the arc length of something. Now, usually we were parametrizing things, but if you think back to 3b, when you did arc length of something like y is a function of x, and you wanted to find the arc length over the interval from a to b, that ended up being the integral from a to b of the square root of 1 plus f prime of x squared dx. Very, very similar formula to what we have here. Surface area is just the two-dimensional measurement that we take, whereas arc length is the one-dimensional measurement that we take. Okay, so we'll come back. Next video, we'll do an example.